going. Had I finished part 2? Had. Okay, so part 3. All 3 are different colours. All 3 are different colours. Did we not just do that? Like, are all 3 different colours, not just these yellow ones? So it's going to be 3 over 14. As in literally that calculation right there, I think. No. This. Sorry, I'm just going to see. No. Okay, I was going to see if I had the answers, to see if I'm getting them right. I should probably check. Yeah, no, don't have the book. Right, let's hope we are. At least 2 have the same colour. So at least 2 have the same colour is basically all of them except for these. Isn't that right? Like I ticked them off there. So there, at least 2 have the same colours and 3 have the same colour. Here, at least 2 have the same colour, so 2 have the same colour. Here, 2 have the same colour. Here, 2 of the same colour. 2 of the same colour. Not these. Here, 2 are the same colour. Not these. Do you know what I mean? So I think it's every single outcome. At least 2 of them have the same colour, except for these ones. So is it just 1 minus? So 1 minus 3 over 14 is 11 over 14, which I think is the probability of at least 2 colours the same. I will whenever I can find my book. It's just not here. But yeah, whenever I can find my book, I'll double check these answers. Right, we keep going for another minute or two. 9 tickets, numbered 11, 12, 13, 14, 15, okay, 11 to 19, are placed in a hat. 1 ticket is taken but not replaced. Another ticket is taken. Find the probability that both tickets are prime numbers. Okay. So prime numbers, we've got 11, 13, 17 and 19. 1, 2, so that's 4 out of 9. That's the probability that the first one is prime. And we want the second one to be prime, but they're not replaced, so it's going to be 3 out of 8. So that is a 6th. Both are even or both are odd. Okay, so both even. So even, 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 even. What's that? 4. Sorry, 4? So 4 out of 9 multiplied by 3 out of 8. That's for even, even. Or we can have odd, odd. So both odd and odd is 1, 2, 3, 4, 5. So that is 5 out of 9 times 4 out of 8. Sorry, I don't know if I said that one correctly, the first one, but I wrote it wrong. So the probability that both are even is 4 out of 9 and then 3 out of 8. And then the probability that both are odd is 5 out of 9, 4 out of 8. And the or in the middle there will become a plus. So that plus 5 over 9 multiplied by 4 over 8. Ooh, I don't know if I did that right. I'm getting 4 over 9. 4 over 9 multiplied by 3 over 8 plus 5 over 9 multiplied by 4 over 8. Yeah, 4 over 9 again. One is prime, but the other is not. So that's going to be like prime, not prime, or not prime, prime. Yeah? So the probability of the first one being prime was what? It was the green, wasn't it? So 4. So 4 over 9 and not prime is going to be 5 over 8. Or not prime is going to be 5 over 9 times prime, which is 4 over 8. So 4 over 9 times 5 over 8 plus 5 over 9 times 4 over 8. And that is giving me 5 over 9. Yeah, and again, I will check those. Right, I'm going to try and get 5 done before I take another break. So 3 girls and 1 boy meet and discuss their birthdays. They discover that 3 of them have their birthdays in the same week. 3 of them, i.e. a 7-day week. Find the probability that the 3 whose birthdays lie in the same week are girls. Okay, so what we want here is girl, 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 I think. So the probability that the first one is a girl is 3 out of 4, and the second one is a girl is 2 out of 3, and the third one is a girl is 1 out of 2. Yeah? 2 over 3, times 1 over 2. So I'm getting a quarter are the chances that all 3 are girls. So then the probability that all 4 were born on different days of the week. Could be a few ways to do this. But all 4 were born on different days of the week. Not sure now. So we have, so the probability that the first person has their birthday on a day in the week is certain. As in, the first person has 7 days to choose from. They can choose any of the 7. The second person has 6 days to choose from. I don't know if it's choice. I don't know if we can do it with a choice because it's not a probability then. So the first person is certain. They can choose any of the 7 days. Yeah, that's 1. Okay. The probability that the second person has their birthday on a different day, because we don't know which day was the first day, so they have 6 days to choose from. First person can choose any of the days. Second person then, that first day is eliminated, so they can't choose that. The third person, 2 days have been chosen or allocated, so they can't have 2 of the days, so there's only 5 days they can have. And then the fourth person, if it's going to be different, can only have 4 days of the week. That makes sense? So this one can have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, so they have all 7. Their birthday has to be in the week somewhere. The next person then, let's say that person was on Thursday, then that only has 6. Okay, that's what I think. I need to check that one though. That's tricky. 7 by 6 by 5 by 4 divided by 7 to the power of 4. So I'm getting 120 over 343 for that one. Okay, so I'm going to just stop here because I have to go home. And I'll do the other 3 then when I get home.